Let's continue our discussion of moles by looking at another conversion factor where moles appear. Remember that moles help us to go from really tiny levels like atoms and molecules up to something that we can measure on a scale. So in this video, we're going to see how we can use the concept of the mole to convert from atoms to grams, something that can be measured in the lab. The new conversion factor that I want to introduce comes from the periodic table. We need to rethink the way we look at this average atomic mass. That is now going to be thought of as a molar mass. That is the amount of mass in 1 mole of a substance. So the average atomic mass from the periodic table is going to be a conversion factor to help us convert between grams and moles. In the example of nitrogen, nitrogen has a mass of 14.01 grams per 1 mole, and that is a conversion factor that we can flip however we need it. So you can write it this way, where grams is on top and moles is on the bottom, or you can write it this way, where moles is on top and grams is on the bottom. Let's look at an example where we're going to convert between moles and grams using the molar mass off the periodic table. The question is, how many grams of lead are in 1.42 moles of lead? You always want to start with the number and the unit that you're given in the question. So in this case, I've started with 1.42 moles of lead. And then you would set up a conversion factor where you're going to have the units you start with cancel out and the units you're trying to go to on the top. So what I mean by that, we started with moles of lead. In my conversion factor, I need moles of lead to be on the bottom. That way, moles of lead is going to cancel, and I'm converting to grams of lead. This number came off the periodic table. That is the average atomic mass for lead. At this point, I can see that moles is going to be canceling out, and my answer is going to be in grams of lead, which was what I was hoping for. I'm ready to put things into my calculator. So when you do this, you always want to multiply by whatever's on the top and divide by whatever's on the bottom. So in my calculator, I'm going to say 1.42 times 207.2 divided by 1, which will give me 294 grams of lead. Moles has canceled, leaving my answer in grams. Let's look at another example, but this time we're going to use the conversion factor the other way. This time we're going to convert from grams to moles. The question is, how many moles of zinc are in 5.78 grams of zinc? Once again, you want to start with the number and the unit that you're given in the question. So start with 5.78 grams of zinc. Then you want to set up a conversion factor, and in your conversion factor, whatever unit you started with needs to go on the bottom. So this time I've put the molar mass on the bottom per 1 mole on the top. So this time, when I multiply across and divide down, I would put in my calculator 5.78 times 1 divided by 65.38. giving me 0.884 moles of zinc as my final answer. And notice that my answer units match the answer on top that didn't cancel out. These units have canceled out. Here's another example, but this time we're going to tack on what we saw in the last video. In our last video, we learned how to convert from moles to atoms or from atoms to moles. Well, now we're going to go all the way from grams to atoms, and every calculation that we do in the concept of stoichiometry has to go through moles. So we're going to go from grams to moles and then from moles to atoms. It's going to be a 2-step process. So here's the question. How many atoms are in an aluminum can with a mass of 14.1 grams? So if you take an average aluminum can, has a mass of 14.1 grams. Follow your process. Always start with the number and the unit that you're given in the question. So I'm starting with 14.1 grams of aluminum. Next, whatever unit I have here needs to go on the bottom of this fraction. So I'm going to use the mass from the periodic table to convert from grams of aluminum to moles of aluminum. And grams needed to go on the bottom so that grams would cancel out. Now that I'm in moles, I'm going to use Avogadro's number, 6.022 times 10 to the 23rd, to go from moles to atoms. Notice that since moles was on the top here, it needed to go on the bottom here so that it would cancel out. At this point, everything in pink is going to cancel. Grams has canceled, moles has canceled, leaving me in units of atoms. I'm ready to put this into my calculator. I'm going to multiply by everything on the top and divide by everything on the bottom. So I'm going to say 14.1 times 1 times 6.022 times 10 to the 23rd divided by 26.98 and divided by 1. That gives me 3.15 times 10 to the 23rd atoms of aluminum. And I know that's a big number, but you're counting atoms. They're really, really small, so there's a whole bunch of them. Just a few things to reiterate about the process. You always start with the number and the unit from your question, and then whatever unit you start with has to go on the bottom of the next fraction. Whatever unit's on the top of one fraction goes on the bottom of the next fraction. And every step is going to involve moles somehow. We're always going to either be coming to moles or going from moles. Here's a similar example, but this time we're going the opposite direction. This time the question is, how many grams are in a sample of copper containing 1.25 times 10 to the 24th atoms? So this time we're starting with atoms and going to grams. It looks similar except for my fractions are going to be flipped. You always want to start with the number and the unit that you're given in the question. 1.25 times 10 to the 24th atoms. Atoms is what I started with, so I need atoms of copper to be on the bottom of the next fraction. The only place you can go from atoms is to moles using Avogadro's number as a conversion factor. At that point, atoms is canceled out and I'm in units of moles. So now I'm going to have moles on the bottom of my next fraction and I'm going to go from moles to grams. When I go from moles to grams, I use the average atomic mass from the periodic table. So 63.55 grams per mole is now the molar mass of copper. Take a step back and make sure that your units make sense. Atoms has canceled out. Moles has canceled out. I've gotten to my desired unit of grams. I'm ready to put this in my calculator by multiplying by everything on top and dividing by everything on the bottom. But you should be cautious because you have an exponent on the bottom. So you want to be very careful how you put that in your calculator. I like to use the E function. So here is my whole process for putting this in the calculator. I'm going to say 1.25 EE, so second EE, 24. That's 1.25 times 10 to the 24th times 63.55. And then I'm going to divide by 6.022 EE, so second EE, 23. Hit equals, and you should get 132 grams of copper. So as you're going through this process, you want to make sure each fraction goes through moles. The tools that you have are Avogadro's number, which can go from moles to atoms, and you have the molar mass off the periodic table, which can go from grams to moles. And then if you will follow my process for whatever unit you have here goes on the bottom here, and then whatever unit you have here goes on the bottom here, that will help you figure out which direction the conversion factors need to be, because remember, they are flippable. You always want to take a step back, make sure that your units cancel properly to give you your desired unit, and then always be careful when you have exponents in the denominator. You want to make sure that you either use parentheses in your calculator or use this EE function that I showed you. That finishes up for us how we convert between atoms to moles and moles to grams. In the next video, we're going to take a deeper look at this concept of molar mass and what to do if you're calculating the molar mass of a compound rather than just an element.